Hello friends, welcome to Kishor Premier Academy, one of the most premier institute for GATE, IES and PSU examinations. In this video, we are going to discuss why we are interested in semiconductor materials. That means, the first thing is that we are going to study the electronic devices. These electronic devices are built up of semiconductor materials. Now you want to know why the electronic devices are built up using the semiconductor materials. That means what is the usefulness of this semiconductor materials. To understand that, let us begin from the fundamentals that we know that the current that will be flowing inside any materials are carried by charge carriers. Any materials. These charge carriers are nothing but the electrons. So we know that the electrons will carry the current inside the materials, not only semiconductors but in every material. Now, to understand why we need the semiconductors, what is the usefulness of the semiconductors, we need to understand that these electrons will move from one point to another point. Then the current will flow. So we need to understand what are the reason behind this flow. That means why the electrons are moving inside the materials. That means we need to understand the three properties of the electrons which are very important for the electrons. The first one is the position, second one is the energy of the electron, the third one is the behavior of the electron. Now, all these three behaviors are or can be changed by different excitations. So, we can also change the position of the electrons by some excitations. We can also change the energy of an electron by some excitations, and we can also change the behavior of the electrons by some excitations. So, what are the excitations? The excitations are the electronic or electron field. If we apply electron field from the externally, then we can change these three characteristics. We can also change the characteristics by applying the temperature. We can also change these characteristics using the lights. So these are the three excitations by which we can change the position, energy and the behavior of an electron. Now let us suppose we have a material, any material. Suppose we have a material like this. So if we have a material like this, then suppose this is any type of material, and if we connect a voltage source across it, and suppose some amount of current is flowing through this material, the applied voltage is the V. So there will be some electric field generated in this direction. This will be the positive polarity and this will be the negative polarity. Now, similarly here will be positive, negative. Now, let us see that we know the Ohm's law. According to the Ohm's law, we know that V equals to I. So from this case, we can find the value of R as V equals V divided by I, where R will have the unit of ohm, V will have the unit of volts, and I will have the units of ampere. So we can have a value of resistance. Now the value of resistance can be found from this Ohm's law for this situation, but the R value that we have deduced from the Ohm's law, this R value is not connected by us externally, built in the material. So we can write that the R is built in inside the material, is not connected by us externally. That means the resistance is a property. Resistance is a property that is the intrinsic property, intrinsic property of any material. Now the question comes, do the resistance property has some value for same value for every material? That is, if we have metals, if we have insulator, if we have semiconductors, do the resistance value will be same for every material or it will be different for different materials? We need to understand that. And if it is same or it is if it is different, we need to understand why they are same and why they are different. So we need to understand what will be the value of the resistance for different materials. For that, if we take the resistance and we have denoted the resistance as R, so let us investigate the resistance itself. We know the resistance of any material is denoted by rho L by A, where L and A, L is the length of the material and A is the cross-sectional area of the material. So we can say that these two property are nothing but the dimension of material. So L and A gives the dimension of the material. Similarly, the rho value, that is this rho, the rho is nothing but the resistivity of the materials. And this resistivity is a property of the material. That means the resistance changes with the rho value as well as the dimension of the material. Now if I look inside this resistivity value, that means resistivity, this resistivity is denoted by rho, which is the property of the material. We can define that it is an internal property of a material which resists the flow of currents. At any constant voltage, the magnitude of the current inside the material depends on the internal property, the resistivity. It also depends on the dimension, but the dimension is given by us. It is in our hand, but this resistivity value is not in our hand. It is the internal property of the material. Semiconductor is such type of material in which we can change the property. That means we can say that inside semiconductor, in the case of semiconductor, if we write in short form is C, semiconductor. In the case of semiconductor, the resistivity value, that is the rho value, can be controlled by us. We can control by the rho value of the semiconductor. If we control the rho value of the semiconductor, then we can control the resistance value of semiconductor, and further we can control the value of current flowing through semiconductor. In this way, we can control the amount of current that is flowing inside the semiconductor by controlling the resistivity. This only happens in the case of semiconductors. How we can control this? There are several methods of controlling the resistivity of the semiconductor material, and the processor first process by which we can control the resistivity value of the semiconductor is the doping process. The second process is the by using different temperatures we can control the resistivity value of the semiconductors, and the third one is by incidenting different intensity, different lights on the semiconductor. We can also control the resistivity of that material. And the fourth one, by varying the purity of the material. So these are the four factors by which we can change the resistivity of the semiconductor. That's why we are interested in the semiconductor material. So if we can change the resistivity value of any material externally, then that is a huge advantages for us. Why? Because if we can control the resistivity value, then we can control the resistance value, and we can control the current also. That means we can vary the current flowing thus the semiconductor at constant power, because the voltage is fixed. If the voltage is fixed, then the input power is fixed. If the input power is fixed, by only doping, by changing the doping, by changing the temperature, or by changing the incident different light, or by changing the purity, we can change the low value. Thereby, we can control the high value also. So this happens only in the case of semiconductors. That's why there will be a low power consumption, low power consumption in the semiconductor devices, because at any constant power you can increase the current, you can also decrease the current. That's why you do not need to change the voltage value to change the current. So this is the most advantageous for the semiconductor. Now let us see why we cannot do this in the case of electrical devices. So if I take some electrical devices such as electrical devices, here I am writing some electronic devices. So some electrical devices are like this. The basic electrical devices are the resistance. Then there is a capacitor, is also an electrical device. Then there is also inductor. So this is the resistance. This is capacitor. And this is inductor. Similarly, if we take some electronic devices, then the electronic devices that I first take, that is the diode. Diode is an electronic device. Similarly, another electronic device is transistor. So this is an electronic device, and there will be the third electronic device is the MOSFET. Now these are the three electronic devices. Now in this case, we can see that, so if I find the value of current, we know that according to the Ohm's law, we can find the value of current here. The value of current will be V divided by R. Similarly, the value of current through the capacitor can also be found as C into dVdt. Let's talk about these two electrical devices. In the first case, we can see that if we want to change the current, then we have to change this resistance. And for each resistance, the resistance value is fixed, we have to change the total resistance. We have to replace this resistance using another resistance, then only the value of current will be changed. Otherwise, we have to change the value of voltage. Similarly, in the case of capacitor, we have to change the capacitance, or we have to change the value of voltage. Otherwise, we cannot change the value of current. So in this way, for the electrical devices, we cannot change the current. And here, the current does not depends on the dimension of the devices. But in this case, in the electronic devices, the depends, current will be a function of dimensions. And also, materials. If we change the materials, we can change the current. If we change the dimension of the devices, then we can also change the current. So this is our diode. In the diode, if we change the dimension, then we get different value of currents. If we change the material, then we also can get the different value of currents. Similarly, for the bipolar junction transistor and also for the metal oxide semiconductor FET transistors. So this is the advantage for semiconductor devices. Now, the most important thing is that you know that inside a material, if we look inside a material, so let us draw a material like this. So if we have a material like this, suppose this is a material like this is the 3D diagram of the material. So in this material, this will be the, if I draw this, then this is the cross sectional area of the material, and this will be the length of the material. So let us denote the length as capital N. And if we apply a voltage across this material, then suppose I will apply this type of voltage, positive, negative, this is the V voltage. So here it will be the positive terminal, here it will be the negative terminal. Current will be flowing in this direction. Now the current will flow inside this, in this direction. So we know that every material, if I talk about any material, every material is a combination of atoms. We know that. So inside the atoms, there are different types of particles. Atoms are generally electrically neutral, and inside these atoms, they are electrically neutral means inside the atoms there are some electrons, some protons, some neutrons. And we know that the electrons are negatively charged and the protons are of positive charges. And the number of electrons inside the atoms is equals to number of protons inside the atom. That's why total number of negative charges is equals to total number of positive charges. So atoms will be electrically neutral. Now suppose if I draw a atom picture, so let us draw an atomic picture. So suppose this is the nucleus, and suppose these are the orbits. The electrons are around the nucleus in different orbits. So let us denote these are the orbits where the electrons are residing. This is the third orbit of the atom. In this third orbit, there are the electrons. So we have seen the proton particles will be here and there will be neutron also, because this is the nucleus. This part is the nucleus. We know that. And there will be several electrons at the different orbits. revolving around the nucleus. I'm just putting some electrons in this way. So electrons are revolving around the nucleus. Now suppose one of the electrons, if the when the electrons leaves the atoms, if any electrons leave the atoms, then the number of electron inside the atom will be less than the number of proton particle inside the atom, because electrons has left the atom. That's why the electron particle number has been decreased, and then the atom will become positively charged, because proton number is greater now. That's why the positive charge is greater. So the atom, if an atom donate electrons, then the atom become positively charged. And suppose you have a material like this. If I take a material like this, and if we give voltage externally in this fashion, then this will be the positive terminal, this will be the negative terminal, this is the applied voltage, and this is the current that will be flowing. Suppose in this material the atoms has donated electrons, and that means we have an atom like this. And this atom has become a positively charged after donating one electron. Similarly, another atom has donated one electron. Similarly, another atom has donated another electrons. In this way, several amount of atoms has donated electrons. And these electrons are now free particles. That's why when this current comes, these electrons will flow in the opposite direction. These electrons will flow in the opposite direction. These electrons flow in the opposite direction because now they are free, and they are free to move, and they will go towards the positive polarity. So the electrons will move towards the positive polarity. That's why we are getting current in the opposite direction of motion. That means electrons are moving in this direction. We are getting the current in the opposite direction. So from this case we can see that the positive charge particle, that is this positive ions, the atoms has become, these are immobile, they cannot move. That's why they are immobile ions. Similarly, the electrons which are left from the atoms becomes free electron, they can move. That's why they are mobile charges. These mobile charges will carry the current inside the semiconductors. Now, the amount of current that's flowing inside the semiconductor will depends on the number of electrons available inside the semiconductor or any material. Now, if we say that the current I that is flowing inside the semiconductor, this current is nothing but the charge that is flowing per unit time. And the charge means the total amount of charge. Let us consider that capital N is the number of number of free electrons inside the material. So every electron will have a charge of, every electron will have a charge content of 1.6 into 10 to the power minus 19 coulomb. So the total charge content of the n number of electrons will be n into 1.6 into 10 to the power minus 19. So we can write, if I denote this 1.6 into 10 to the power minus 19 coulomb as Q, so we can write the total charge will be capital N into Q divided by T. So we have found that I equals to capital N into Q divided by T, where this Q content, Q factor is constant, as well as this T will also constant, because T is nothing. T can be written as L divided by B, where L is the length of the semiconductor, and this length is fixed, and V is the velocity of the electron. The velocity of the electron is also fixed, so T, the time, is also fixed. So the only variable here is the electron content, that is the number of electrons inside the semiconductor. So we can say that the current flowing through the semiconductor is proportional to the total amount of electron that is available inside the semiconductors to carry the current. If we, and this total amount of electrons, that is total amount of free electrons, and the number of free electrons can be controlled externally by us in the case of semiconductor. That means the current content can be controlled externally by us. So from this we can conclude that we can control the current of the semiconductor material by changing the total amount of electron, that is the free electrons available inside the semiconductor. The total amount of free electrons inside the semiconductor by different methods: doping, temperature, light incidence, purity. These are the factors that we have already discussed. So depending on this total amount of electron, that is capital N, this is the total amount of electron, rather we can say it is free electron. Depending on this capital N, the semiconductor or any material will have some property, that is the resistivity will also be depends on this. So we know how it is depending. We know I equals to V divided by R. If I equals to V divided by R, so we know V divided by rho L divided by A. So rho was the resistivity, and this rho value depends on this capital N. So if we make the reciprocal of the rho, this is denoted by conductivity. So conductivity of, we can say that the conductivity of the semiconductor can be changed by us externally by controlling the value of total amount of electrons. That's why the current inside the semiconductor can be varied at constant power. So we can say that sigma, that is the conductivity of the material, is equals to 1 by rho, that is the resistivity of the material. If we have some value that like conductors inside conductors, the total amount of electrons or the number of electrons per unit volume is of the range of 10 to the power 23 to 10 to the power 29 number of electrons, number of free electrons per unit volume. Here volume is centimeter. Similarly for the insulator, it is found that the total electron concentration is 10 to the power 6 to 10 to the power 7, which is very low of free electrons per unit volume in centimeter. But in semiconductors, it is found that the total electron content per unit volume is 10 to the power 2 to 10 to the power 16 number of electrons, number of free electrons per centimeter. And this value has a range. We can change this value depending on different external operations. So we can say that the current through semiconductors, current through semiconductors is analogous with the number of mobile electrons found inside semiconductor, and this is in our hand, so we can control that. That's why the semiconductor materials are very much important in the case of electronic devices because we can control the current of the semiconductor by our own. But in the case of conductors and the insulator, we cannot do that because we cannot change the number of mobile electron count inside the insulator and conductor. The total amount of electron can be changed or varied externally only in the case of semiconductor. That's why semiconductor is very much important. And last of all, do not forget to subscribe and like our channel to get more videos like this. Thank you.